Hello, and welcome to another episode of PLC programming. In our last video, we already looked at the interface of the programming area where I showed you instructions. I also showed you testing, task libraries, and add-ins. We also did how to change from direct addressing to indirect addressing, which allows us to call our function block from inside the OB1 and connecting our input and outputs to it directly. The program, I'll just go ahead and delete this ones. I was showing you some basic instructions that you could use. Um, in our last discussion, we used ladder logic. Basically, you can see how a PLC is programmed. It looks very graphical. Ladder logic looks quite graphical because it originated from relay logic. So ladder logic, which looks very similar to relay logic, you can directly see how the code is done. This is a normally open switch. This is a coil, and this is usually how you would wire this in a PLC, right? In a PLC panel. And that's how we do ladder logic. Now today I want us to do the same thing in SCL, which is the second language, which I would also show you in this programming. SCL is much more advanced. SCL basically is structured control language, which fulfills also one of the other five languages from the IEC 61131-3 standards. So how do we do this? I'll, I'll add a network below each network, and we will do the same thing in SCL just to show you how this works. After that, we will also go through an example from one of our past videos. So when you right click on a network, I just did a right click, you see so many things right here, right? I already discussed with you about cross references. In this case, what we want to do is to insert SCL network. So when we insert SCL network, then the PLC creates another network where you can type in your SCL code. And if you look up here now, you would see that the instructions we had here earlier, which were directly for ladder logic, have changed. What you have here are now if, case of, for, to do, while, region, things like that, which are the languages, or let me say the instructions that you can use for SCL. If I click on the ladder logic network, it will change back to ladder logic, as you can see. So inside this block, Siemens allows you to run ladder logic and SCL or STL, as the case might be, together in one block. It's also because we have created this block in ladder logic. For example, if I double click on this, like I want to add a new block, it would ask you what language you want to use, and that's if I select function block or function call. For example, let me say function block, or let's just stick with function call because I don't want to create a DB yet. And you see it's showing what language do you want to use. If you create this block in ladder logic, it then gives you the opportunity to also run STL and SCL code inside of it. However, if I create this block now in SCL and I click OK, I can only run SCL inside of it. So let's check. I hope it stays the same from the other versions. Yes. So you see, I don't have any chance here like network 1, network 2. If I do a right click, I wouldn't have the option to include the ladder logic inside this. See, there is nothing like insert, whatever. It's only SCL that I can run this. So these are some of the differences that you need to know. If you already know in your program, in your block, you would like to run ladder logic for some networks because they're easier to troubleshoot, and you also want to run SCL or STL, then it's better to create your block using the ladder logic. Now, what do we have here? We said if this switch is on, then the room light is on. If this switch is off, then the room light is off. In SCL, we use what we call if logic for that. So I can click on if here, and it already gives me the structure directly. You see? So I can say if, then what's the condition? We said if switch. I can drag this switch to this, right? And then it says if switch, which go in there, then yeah. So if switch, you can also say if switch equals true. You get? Or you can just leave it as if switch, because when you leave it as if switch, it makes your code cleaner, and the PLC already understands that you're checking this condition either on or off. The PLC already knows that's what you want to check. And then we said if switch, then blah blah blah. If switch, then room, right? Yes. So we have some errors here, right? Basically, I just wanted to show you how this runs. So normally you would say if this, then dash equals true. Let's see if that works. So we still have some errors. So there is a way by which we can assign this, right? Now this works. Instead of running this if switch, then we don't have errors right now, right? So we have the same code here as this. As you can see, this looks more easier for this specific code, right? For this specific thing we're trying to run here. However, there is also a cleaner way to do this, because this room light equals to this switch. Whatever this switch state is what this room light state would be, right? So we can directly just go down instead of that and say room light, right? And this is how we assign states in SCL. Room light equals switch. And then we have to close it with a semicolon. And put it up over this. So basically, this if that we have here is the same thing as this, because this looks similar to this, and this has saved us like 4 lines of code into 1 line. So I can delete this, right? And basically this is it. What we have here is this. So room light equals switch. Basically, if the switch is on, room light is on. If the switch is off, room light is off. That's that. If we want to do the same thing for the disco light, basically the same, say insert SCL network. It creates a network below here. So how do we do that? We just go directly. Here we use direct addressing. So I can just copy this. I can copy this disco light equals clock 10 atts. We close it with a semicolon. Finish. So basically we have our SCL code here as well. And because here we use direct addressing, you see, but in SCL it picks the tag name. Now you start seeing the differences. In ladder logic, it shows you the direct addressing, right? In SCL, it picks the tag name. directly the tag name that you've used in your tag tables. That's what it picks. You understand? So when you hover your mouse on top of it, then you can see the address. You see the address there in yellow? That's how you see the address in SCL. In ladder logic, it shows you the addresses directly. That way you can troubleshoot easy. For motor start stop, this is a bit more complex, but we will also do that. I'm inserting an SCL uh, table. So there are different ways by which we can do this. The easiest way is because we're using an SR flip-flop. We're using an SR flip-flop. So we can basically go into our logics. Okay, so again, because we are inside, very good. Because we are inside an SCL network, you see the type of instructions that we get. If I click on the ladder logic, this would change. This would change. See, we have a very long list. See now, here we're not able to drag this here. We can only drag it here. See, we cannot drag it into this network because it doesn't work with the SCL function. This is similar to when we were configuring our hardware, when we're doing our hardware configuration. When you click on the PLC, you only get devices on the library that can work with the PLC. When you click on the switches, you only get devices that can work on the switches. So that's how it also works. So I'll go back to the SCL and see if we can get an SR instruction here. So I'll go to bit logics, timer, counter. We don't get that, right? I don't see that. Okay, but it exists. I know that it exists somewhere. Of course, you can use SR um, flip-flop in logic as well. So let's try to program this. We can do it in different ways, right? First, we say this is what we're trying to set. And as you've seen from the past networks, our output is what we usually try to set all other things to, because that's the state we want to set. So I'll go to our motor coil and say our motor coil equals, because everything we're doing here is setting our motor coil, this output. So I'll say our motor coil equals blah blah blah. You understand? The output comes first in SCL. In ladder logic, the output comes last. You want to run all your logic, your output comes last. In SCL, your output actually comes first. Motor coil equals, then you set whatever you want to set. Now let me see if I'm able to pick the SR flip-flop. Good. Because I know this operand exists. See, I'm picking it right now. Right? So because I typed SR, it's giving me this. Let's see what happens. No, this is not what I want. So what it's giving me is this. Let me go to definition. So you can always click on an item and see where it is defined. Just like you can also click on an item to see where it is being used. This is not what I want. So I'll go back, type SR and in bracket. Now in this SR, which is this flip-flop, this flip-flop, I have the set, I have the reset, I have the Q, which is the output. I've already set the Q, which is this um, motor coil. Now I need to set all other things, right? So I can say set, I know this S is set equals, then we have our motor start, and not, because this is the NOT gate, right? This is the NOT normally close. So when this and not this. So when you're doing this now, you start remembering your logic gates that you did right there in school. set equals this and this, then no, I don't think we need then here. Okay, equals this and this, and then we go down, we said reset. We also need to define what reset is, and then our reset is motor stop, right? So this should be the end of the program. Let me see if I close with a semicolon. Okay, so I have some errors here. Basically, I've not been able to define this properly. This is version 20, so probably I'm doing something wrong, or okay, I need to close the bracket as well. Yes, yes, I need to close this bracket. I opened this bracket here. I need to close this bracket, and then I can add a semicolon. So it looks like okay. Okay, let me see if this works. It doesn't look like it worked in any way based on what I can see. I'm just trying to compile to see if maybe the PLC can bring up the SR flip-flop. If that doesn't work, then we can write this code in another way, right? It's compiling. Okay, basically there are still errors, right? We can take time to troubleshoot this. I can look, of course, this should work, right? This should work in one way. We can take time to troubleshoot this, but let me see. Have I declared a variable? Let me see. No, I don't want to spend a lot of time on this. So let's do this in another way. Just like we had two codes here earlier and we picked one, I will do the same thing here. So we can, instead of using the SR logic, we can code it in a different way, right? Because we know what we want to achieve. So let's code it in a different way. So what we can do, because SR is basically a set and reset call, we can just use that directly. So we can use the if logic here. If, so we say if motor start, if motor start and not motor stop. So I'll just copy this. If motor start and not motor stop, right? Basically, this is our set, right? Then what do you want to do? So it says, what is the statement section if? Then I want to say set motor coil. This is what we want to set. Set the motor coil, right? I need to add a semicolon here. And then we need to end our if. Or we don't need this set actually, because the if logic should work without this. So why do I have this error here? So I needed to add the true in front of the motor coil right here. If motor start and not motor stop, then motor coil equals true, which is what we have here. If and not this, then motor coil equals true. So how do we reset this, right? We can end it here and start another if below it, because as I mentioned in the last video, the PLC will run this code. It will keep the output in its memory until it's done before it sets output. However, to keep your code clean again, right, we can also just put it inside the end if statement. So instead of that, we can use else if statement, right? So we say else if motor stop, right? Else, if motor stop is true, you get? Else, if motor stop, then then motor call will be false. So we can end this. Correct. So I can also add this statement section else if. So you need to be very careful here. Let me zoom this so I can show you properly. You don't complete the else, ELSE, right? This is a function in the PLC. It is ELSIF, else if, not else if. Just get note of that because you can do that mistake, right? So you have to follow this logic. So basically, I can delete this and we have our code. We have the same code which we have up here, which states if this and not this, then this is on. However, you reset if this is true, then this doesn't work. So the PLC starts from top, it checks this code. Okay, it sees that okay, this is correct. Then it says okay, the motor coil has to be true, but it doesn't set it true first yet. It still runs all the code in the PLC, and then it comes here and says, oh, else if motor stop, then motor coil is false. At that timing point, if motor coil is true, then this motor coil will be off. So it's basically resetting itself back. Do you understand? Yes. So to write a statement, um, to always put notes inside your program. I've advised you earlier so that when someone is reading your code, they understand it clearly. You can always put notes like this. And how to do that in SCL is to add a forward double slash. When you add a forward double slash, whatever you put on that line becomes just a comment. We call this comment. So you need to ensure that you learn how to comment your code properly. What we have now, we don't have errors, we can compile. But like I said, like you know, we have the same program running in different networks now. We have two different programs running on the same network. So what I would like you to do is to try different logics using SCL, and you're lucky in this case of artificial intelligence. You can also tell artificial intelligence, chat GTP, whatever, to give you some simple SCL codes that you can run on the PLC. You declare your inputs, declare your outputs, see how that works. And in the next video, we will be discussing this topic which we had before now. We need to program Mr. Orange Man's house. So in the next video, we will talk about this and see you there. Thank you very much.